Okay, so let's discuss plate tectonics. Okay, um, originally the topic covers seafloor spreading and yung interactions between plate boundaries. But in general kasi, nung nagbabasa na ako ng books, I found out that well, the discussion of that module is focused talaga on plate tectonics. Okay, and this is um, this is one of the theories na nagde-describe ng planet natin. Okay? So if you're familiar with the picture on the right, that's a picture from the movie Finding Nemo, 'di ba? So that there is what we call a trench. Okay? So this is like just a simplified version of a trench. Okay? So um kumbaga this is not the trench na nakikita talaga natin sa seafloor o yung nagiging produkto ng mga interactions between boundaries. But the idea is there that it's a deep, paano ba siya? Parang deep na crevice or malaking crevice sa planet natin. Okay? So, plate tectonics. So, what is the plate tectonics theory? So, while I was reading, I also discovered that the plate tectonics theory was a theory that grew from Wegener's theory, yung continental drift. So parang it's as the scientific community grew, as instruments were produced, yung mga mas sophisticated na instruments na ginamit to understand or to describe the characteristics o yung pinaka surface ng Earth as well as yung ibang mga pailalim na characteristics niya, what do you call that? Yung layers, okay? Nung tinatry i-describe ng mga scientists yon throughout the time, nagkaroon sila ng theory, okay? So they proposed a theory. Okay, so the plate tectonics theory simply says that yung Earth, okay, in general, ito, yung lithosphere, it is divided into what we call plates, okay? It is broken down into what we call plates. Kumbaga, ayan, kasi the lithosphere is described as the uppermost mantle and the overlying crust. Okay, yun yung pinaka-layer na pinagsama-sama nila. And this lithosphere, kumbaga parang solid siya, 'di ba? So medyo solid talaga siya in um, characteristic. Okay, solid siya. But under it, meron kasing liquid or fluid na nasa ilalim niya, which is yung asthenosphere. Okay, so, ayan, wait lang, sorry. Ito pala, it is said that the lithosphere is mas manipis siya sa mga oceans and it is thicker in continents. Okay, so continental lithosphere is thicker or thickest as compared to those found in the ocean. Like I said, yung lithosphere natin, yung solid na portion ng surface natin, again, this is the uppermost mantle and the crust, nag-underlie siya or nasa ilalim niya ang asthenosphere. Okay, so this is considered as the weak region in the mantle. And since medyo malalim siya sa surface ng Earth, um, yung rocks dito, they are experiencing high pressure and high temperature. Okay, so these are stresses um, that can make them change their characteristics. So hindi sila magiging solid, mas magiging fluid, parang mas magiging viscous yung characteristic nila. So some of them turn into magma, ganyan. Okay, so yun yung asthenosphere. Okay, so and through convection currents, 'di ba? Nagkakaroon ng movement doon sa fluid na yon o yung nagkakaroon ng flow, okay, due to convection current. So the lithosphere, 'di ba? So you can imagine the lithosphere is a solid component ng surface, and then sa ilalim niya is liquidy or fluid. Fluid yung characteristic, 'di ba? So parang nakalutang sila or um, um, in that perspective, kumbaga parang nakalutang sila, okay, in a constant moving fluid. Parang ganun yung idea. So detached, hindi siya yung as in solid talaga. So kung titingnan natin dito, ito yung mga plates na tinutukoy natin. So yung lithosphere daw natin, it is divided into several segments called plates. Diba? Ito yung mga tinatawag nating tectonic plates. Okay? So, these tectonic plates, sa ilalim nila, yun yung asthenosphere, di ba? Which is fluid in nature. It's flowing. Okay? Moving siya. So, imagine niyo na lang, nasa ilalim niya, medyo liquidy. So, in short, these plates here, they are subject to movement din, di ba? Kumbaga, um, static sila at some degree, but since yung asthenosphere ay constantly moving, the plate itself is slightly moving din, okay? With respect or with reference to other plates, ganun din, okay? They can collide with other plates, they can grew farther from other plates, they can slide past each other and such. Okay, so these are the main tectonic plates na makikita natin sa Earth. So you have the Arabian plate, you have the African plate, the South American plate, Nazca plate, Caribbean plate, blah blah blah. Okay, North American plate. Ito dito, this is notably the biggest is the Pacific plate. Yan, makikita nyo. And we also have our own, the Philippine plate. Okay, so North American plate, Eurasian plate, and Australian Indian plate. Okay, so ganyan yung characteristics ng mga plates natin. Okay? Okay, so like I said, in reference to other plates, since liquid or fluid yun nasa ilalim nito mga plates na to, the boundaries of these plates can have different interactions. Okay, pwedeng magkaroon sila ng iba't ibang interactions with each other. Okay, so since they are yan nga in constant motion, some of them can collide with other plates, some of them can groove no, not groove far. Some of them can move far away from each other or can move away from each other, and some of them can slide past each other. Okay, so yun yung tatlong tinutukoy nating plate boundary interactions. Okay, so question muna. Okay, one question. Since plates are always in motion, distances between places could change. Okay, so maan natin yon. By simple logic, we can identify that, diba? That some places, some distances between places could change. Okay, the first question would be, will Marikina and Baguio have the same distance after some time of constant plate movement? Okay, you can answer, guys. Will Marikina and Baguio have the same distance after some time of constant plate movement? What do you guys think? Will they have the same distance? Okay, sabi ni Miss Doria, no. Si Zai, no. How about the others? Will Marikina and Baguio have the same distance after some time of constant plate movement? Anyone? Anyone else? How about yung iba? How about yung iba? No, no. Sige, yung iba pa. No. How about for the others again? No, no. Yes, no. Yes, okay. So some answered yes. Actually, very few answered yes, but most of you answered no. The correct answer is yes. They would have the same distance. Balikan natin. Why would they have the same distance? Looking here, um, yes, they are in the same plate because, ayan no, isa lang yung plate natin the Philippine plate. Our country is located there, okay, somewhere there. So, basically, kung titignan natin, since Marikina and Baguio, hindi naman, they're in the same, ano, di ba, what do you call, they're in the same, um, landmass, 'di ba? For example, yung Luzon, 'di ba, isang malaking landmass siya. So nandun lang naman sila sa isang place na 'yun and that is not yung landmass na 'yon is still under a bigger tectonic plate. So if magkaroon man ng plate movement, the distance between Marikina and Baguio will still be the same. How about for the second question? Will Marikina and New York have the same distance after some time of constant plate?
No po.
Very good. No. So since magkaiba sila ng plate, since New York and Marikina would be on completely different completely different plate, they would have changing distances. Okay, medyo magva-vary yung distances nila between each other kung magkakaroon ng plate movements. Okay, pwedeng medyo mas maging close, pwedeng medyo mas maglayo. Okay, so sige, tignan natin. So from the discussion a while ago, okay, so plate boundaries have different interactions, okay, between each other. Divergent boundaries, or what we call constructive, kaya siya tinoterm na constructive because kapag daw po nagmo-move apart, okay, divergent is the plates moving apart from each other, okay? Kapag daw po nagmo-move apart yung plates natin o yung two plates natin, nagkakaroon ng upwelling ng magma. Okay? Nagkakaroon ng upwelling ng magma. And sometimes, kung hindi pa man magma yan, let's say rock pa lang yung aangat dyan, sometimes yung pag-decrease ng pressure, di ba? Since mainit siya, tapos nag-decrease yung pressure, that can also produce magma, di ba? Pwede din silang maging magma. So magfo-flow out, mag-upwell, kung magma man yan or kung hot rocks man na magto-turn pa lang into magma, mag-upwell yung material na yon papunta sa taas. Okay? So, and since the plates are moving, may gap na mafo-form, and the magma or the material that flows out from the mantle will eventually also cool down. Okay? Magko-cool down din siya, forming a new lithosphere. Okay, magkakaroon siya ng bagong layer ng lithosphere or bagong layer ng crust. Okay, so dito pumapasok yung tinatawag nating seafloor spreading. Okay, so mamaya mas madidiscuss natin siya further. So sa divergent boundaries, doon talaga nangyayari yung seafloor spreading. Kaya siya tinawag na constructive because you are constructing or nagke-create ka ng bagong seafloor, okay, bagong crust. Ganyan. Okay, convergent boundaries. So if divergent boundaries ay nagmo-move apart or nagmo-move away from each other, convergent boundaries are termed as destructive, meaning nagsisiraan sila or nagko-collide sila. Okay? Sometimes the collision can result to I think this is sometimes the collision can result to subduction, in which yung isang plate nagmo-move siya downwards. Okay? It moves downwards doon sa isa pang plate. Parang, eto, makita nyo dito, di ba? Dito, makikita nyo, sorry. Yung plate na to originally, for example, ganyan siya. And nung nag-collide siya sa isa pang plate, okay, nag-collide siya sa isang plate, nag-slide down to. Napunta siya sa ilalim. Okay? And itong napunta sa ilalim, eventually, masusunog din yan, tawag dito? Maaano siya, magme-melt and magiging part na din ulit ng mantle. Kumbaga parang mare-recycle siya ulit. Okay? So dito, pwedeng mag-move beneath or mag-descend siya beneath in the process called subduction. But sometimes, yung collision, pwede siyang mag-form ng mountain system. So sa case na to, for example, yung collision ng dalawang plates na to, paangat. Okay, medyo paangat naman yung direction nung material ng mga plates na or nung nagko-collide na mga lithosphere. Okay, paangat siya. So magfo-form siya ngayon ng system, ng mountain system. So sometimes ganon. Okay, so yung mga mountain systems natin or yung mga parang bulubundukin natin, usually ganyan yung interaction na nangyari. Nagkakaroon ng convergence ng dalawang plates, ng collision, pero yung movement ng plates pataas. Okay, hindi siya subduction. Okay. Next, we have yung transform fault boundaries. So ito yung tinutukoy ko na sometimes nagsa-slide past sila each other. Okay? So ito, kung makikita nyo, nag-slide past lang sila sa each other, sa isa't isa. Okay? So remember, kung naaalala nyo yon, pwede natin ma-identify if it is left, ano yung term doon? If yung their alignment niya ay left, I think it's left alignment, or kung right yung alignment niya. Can you remember kung paano natin ma-determine? So meron kang reference, which is yourself, and then paano natin na ano yun, determine? Can you guys remember? Anyone?
Kung saan, naka-face po sa...
Okay, very good. Kung saan ka naka-face, kung ano yung movement nung nasa harapan mo,
Yun po yung
alignment niya.
displacement.
Very good. Okay, so kung nag-move, yung nasa harap mo ay nag-move pa left, yun yung alignment niya pa left. If yung movement niya ay pa right, yun yung alignment niya pa right. Okay? I forgot the term. Basta left and right something yun. You can check the ano later. Okay, so sa transform fault boundary, ganon yung nangyayari. They slide past each other. Okay? So, most of the time, divergent and convergent interactions yung nangyayari sa plates. Ay sabi doon sa nabasa kong book, if I'm not mistaken, 40% ng plate boundary interactions ay divergent, another 40% is for convergent interactions. Tapos yung remaining 20% daw ay for transform fault. So, ito medyo mas rare siya as compared dito sa constructive and destructive na boundary interaction. So, kung tutusin, parang nag-equate lang din yung dalawang bagay because dito, nababawasan yung plates, nare-recycle siya, di ba, napupunta sa mantle. Dito naman, nakaka-create ka ng bagong seafloor or bagong lithosphere, kumbaga. So, parang naaano lang din, nare-recycle lang din talaga yung material. Okay? Okay, so seafloor spreading. So like I said, sa divergent boundary ito nangyayari, yung seafloor spreading. Dito natin nakikita na merong constructive na process na nangyayari sa tectonic plates natin. Okay, so it occurs in divergent boundaries. And if you notice here, as the seafloor spreads, okay, as ito yung dalawang plates natin, ano, for example, this one and this one. So at a certain time, okay, so submodule nyo, this is already described, the mid-ocean ridges. So at a certain time from the mid-ocean ridges, wait lang, I'm sorry, from the from the mid-ocean ridges, magfo-form ka ng bagong seafloor. Okay, so this is the new seafloor. Dahil medyo naglalayo ngayon dalawang plates natin, may material na nag-spew out dito sa mid-ocean ridges natin, forming our new seafloor. Okay, as time goes by and each of the plate keeps moving in the same general direction, magsispew out ng material yung dun sa mid-ocean ridge. So forming another ocean floor or sea floor. Okay? As again, time goes by, magfo-form ulit siya ng bago na sea floor. So kung manonotice nyo, you can actually divide the segments of the sea floor from youngest to oldest, okay? In reference with the mid-ocean ridges. Okay? So in reference to the mid-ocean ridge, the youngest would be the ones closer to it. Kasi yun yung kakalabas pa lang na material, kaka-cool down pa lang na material. As you move farther away from the mid-ocean ridge, your seafloor gets older. Okay? Mas tumatanda yung seafloor natin. Okay? So hopefully you understand that part. And here, the seafloor, yan, yung makikita nyo, the magma from the asthenosphere, di ba? Kasi nga, sa divergent boundaries, yung magma from the asthenosphere, it moves upwards towards the mid-ocean ridges, spewing out the material, di ba? So, yung asthenosphere natin yung nagsusupply nung constant na material na ginagamit doon sa pag-spread pa ng seafloor, yung pag-construct ng bagong seafloor. Okay? So, sometimes, ayun nga, the magma coming from the asthenosphere is constantly recycled through convergent boundaries naman. More specifically, yung subduction processes. So, sometimes the plates are yung material, yung lithosphere na nasa plates, if it moves downward another plate, it gets melted again and then be part of the mantle ulit. Okay, the asthenosphere in general. Okay, so paano nga ba natin nasabi that the seafloor is actually spreading? How did the scientists figure out that the seafloor is actually spreading? Okay, o yan. Sabi ni Ms. Chris, you can say that the seafloor is spreading because, okay, because of the following evidences. Okay, because of the following evidences. So several experiments of scientists, um, parang a great expedition funded by I think the US government, um, gusto nilang ma-identify yung layers ng surface ng Earth natin. So they did an extensive drilling of the ocean. And siyempre, pag kumuha ka ng sample, 'di ba, downwards, makikita mo that it can be divided into layers and such. Okay? So makikita mo na nag-iiba-iba yung layers natin. Okay? So mamaya ma-explain pa natin to. So that is one evidence. At the same time, these are also evidences, these two. Etong paleomagnetism, binanggit ko lang siya kasi yung concept nitong magnetic anomalies and reversals is from paleomagnetism. So basically, paleomagnetism is like a fossil record for magnetic interactions between um, magnetic minerals and the Earth's magnetic field. Okay? So itong dalawa na to. So paano ba na-conclude ng scientists that the Earth nagre-reverse yung magnetic field ng Earth, ganun ganon. Okay? So doon natin malalaman. Okay, like I said, nagkaroon ng extensive ocean drilling. Okay? So nagkaroon ng extensive ocean drilling. And they discovered that from the mid-ocean ridge, habang nagmo-move ka away from the mid-ocean ridge, if you're moving away from the mid-ocean ridge, they noticed that the layers of sediments or the layers of the surface of the seafloor, it gets thicker or mas nadadagdagan siya as compared to those nearer the mid-ocean ridges. Okay, so why do you think that those farther away from the mid-ocean ridges have more sediment layers as compared to the ones closer to the mid-ocean ridges? What do you think? Or why do you think mas madaming layer to si mas malayo sa mid-ocean ridge? Anyone? Why do you think that this one here has more layers as compared to this one here? Okay, very good, Miss Danielle. It accumulated. Okay, it accumulated meaning the seafloor found in this particular area here, for example, it has been here for a long time. Okay, matagal na siyang nandito or matagal na siyang nananalig sa seafloor natin. Pag matagal na siyang nagse-stay dyan, ibig sabihin lang nun, there is more time for other sediments to form. Sediments from yung mga material na ine-exude ng mga organisms. At the same time, pwedeng may layer dyan ng mga dead organisms din mismo or dead corals, dead whatever. Okay, so sometimes ganon. Okay, so yung layers of sediments na yon, it accumulated over time. So meaning, mas matagal na tong nananalig sa planet natin. Eh dito, napansin nila, mas onti yung layers, mas onti. Meaning, kaka-form niya lang, kakagawa lang sa kanya, kaya wala pa masyadong time for other sediments to fall on it. Okay? Wala pang time for sediment layers to form above nung bagong seafloor natin. Okay? So that is the logic for ocean drilling. So they concluded that, oh, okay, as you move away from the mid-ocean ridges, layers would become older na. Okay? Layers would become older na. Meaning, from the point of the production of the new seafloor, it nagmo-move farther away. Okay? So, after some time, for example, after some time dito sa mid-ocean ridges natin, magkakaroon ulit ng bagong seafloor. Tawag dito? Replacing these, the ones here. Okay? Replacing the ones here. So, ito, magmo-move ulit yan further away from the mid-ocean ridge. And then, lahat ng layers na to, magmo-move ulit further away from the ocean ridge. Kumbaga, parang magmo-move ulit yung line. So, ganun yung process. Okay? So, that's why mas ma-determine talaga natin yung age ng seafloor kahit gamit lang tong samples ng ocean drilling. Okay? Next. Okay. So, ito yung tinutukoy kong concept ng paleomagnetism. So, basically, yung mga minerals natin na magnetic in nature like magnetite, okay? Like magnetite, in high temperatures, usually hindi pa nila na-arrange yung sarili nila in the direction of the magnetic dipole. Okay? Hindi pa nila na-arrange yung direction nila at high temperatures. Medyo random pa yung direction nila. As the magnetic mineral crystallizes, like magnetite, as it crystallizes, na-orient na nila yung sarili nila to the magnetic dipole nung Earth at that current time. Okay, that is important to note, at that current time. Kasi once this crystallizes at na-orient na ng magnetic mineral natin yung sarili nila to the magnetic dipole of the Earth at that current time, hindi na mag-move yon. Okay? It will not move. Its orientation will not move anymore. So, kumbaga, ano na yon, solid na yon, or kumbaga, naka-create ka na ng pinaka-record. Okay? At that certain time, ito yung orientation ng magnetic dipole ng Earth. Okay? Now, after some time ulit, okay, after some time, inimbestiga natin tong rock 1 versus rock 2. Okay? Rock 1 versus rock 2. This one, for example, is older. Okay? This one is younger. So, manonotice natin that the magnetic dipoles can differ. Okay? Sir, gusto ko walang magnetic field. Hindi naman, paano ba natin sasabihin to? I don't think so. Kumbaga parang, dahil din actually sa mga magnetic na minerals, dahil din sa mga metals, 'di ba? Kaya nagkaroon ng magnetic field yung planet natin, 'di ba? Dahil dun nga sa core. So, dahil dun sa constant movement ng mga magnetic na material na yon, yun din yung nakapag-create ng field sa planet natin. So, in turn, yung other magnetic materials din na nahanap farther away from it, nagkakaroon ng interaction between that magnetic field. Okay? So basically, the magnetic dipoles o yung orientation ng magnetic minerals natin from two different rocks can actually differ. Okay? For example, ito, ganyan yung direction niya. Tapos yung isa, kunyari, medyo mas paganto na siya. Okay? So magkaiba. Kaya daw po, sabi ng scientist doon sa, medyo hindi ako super duper nag-in-depth na aral dito, pero doon sa nabasa ko parang sabi na, kaya pag in-identify mo yung magnetic dipole in this current time, for example, nandito ako, in-identify ko yung magnetic dipole, tapos, tinest ko yung magnetic dipole ng isang bato na hawak ko, for example, an old rock, manonotice ko na magkaiba talaga sila. Okay? Yung current na magnetic dipole, magkaiba doon sa rock na tinitignan ko yung magnetic dipole. Okay? Yung mini-measure ko yung magnetic dipole. Kasi nga, from that current time, yung record ng rock na yon, yung magnetic na minerals na nandun, nag-orient sila to that times magnetic dipole. Hindi dito sa ngayon sa current na time. So basically, parang na-fossilize nila, napuput nila into record yung magnetic dipole at that current time. That's why yung magnetic anomalies at saka reversals na-identify natin. Okay? That's why we can identify these anomalies and reversals. And these are all evidences for seafloor spreading. Dito, makita natin, yung reversals yung diniscuss sa module nyo. And it is, medyo mas madali nga naman talaga siyang intindihin. So, na-discover ng mga scientists that over time, yung dipoles, yung magnetic dipoles ng Earth, nagre-reverse siya. Okay? Nagkakaroon ng reversal yung magnetic, nagkakaroon ng reversals yung magnetic dipoles throughout the time ng Earth, yung formation ng mga bagong seafloor and such, nagkakaroon ng reversals. Okay? Etong mga pangalan na to, ang mga pangalan niya ng scientist daw na pang malaki yung ambag sa science ng magnetism, if I'm not mistaken. So, pinangalan yung mga layers. For example, itong current na layer ng mga rocks, ng mga magnetic na orientation ng magnetic minerals natin, normal yung orientation nila. Meaning, yun nga, normal. Yun yung kay Brunhes. Pag mag-move ka further away in time, in the past, nag-reverse daw siya during Matuyama. Okay? May unit yan eh. I think it's called a cron. Yan. I think it's called cron. If I'm not mistaken, it's called a cron. Yan, Gauss, normal, Gilbert, reversed. So during some time down, na-discover na as the seafloor is actually spreading, yung distinct na layers na na-form niya ng mga bagong seafloor, 'di ba? Katulad dun sa wait lang, I think I have a figure. Wala. Katulad dun sa um, sa drilling natin, nagkakaroon ng reversals yung mga layers na yon. So na-identify natin na nagkaroon ng reversal. Bakit nagkaroon ng reversal? Ganyan. Maybe due to like differences in movement of the yun nga magnetic material and such. So basically parang naging na-fossilize yung nangyayari during that time. Okay? So we have a fossilized records in the form of the um, magnetic minerals found in rocks. Okay? Okay, so are there any questions? Let me just stop my